Hello, everyone, and welcome to the Surface Ventures workshop in partnership with Optimal Instruments. Before we go any further, I just want to check that we're coming through loud and clear. So could you please write in the chat box where you're joining us from today? So the chat box can just be found on the right-hand side. Okay. Whilst we're waiting for some of the responses to come in, I'll just introduce myself. I am Sam McMaster. I am the event manager here at Surface Ventures, and I'll be your host for today's session. Surface Ventures is a non-for-profit organization, and our mission is to provide world-class surface engineering education for both academia and industry. Every month, we'll bring you a sector-leading speaker to present the current challenges and future trends in surface engineering, alongside surface engineering workshops like today and live equipment demonstrations. Okay, lovely. Looks like we're coming through live and clear. Someone from Romania, fantastic. I don't think we've had someone from Romania to my knowledge before. Poland, SKF in the Netherlands, excellent. All great places. Great to have you with us today. Alrighty. So today we will be featuring Patrick Bowe and Gregor Patzer of Optimal Instruments. So I will just read out their bios so you're aware of their background before we invite them on stage. Okay. So Patrick, who graduated engineer of automotive engineering. He's also been an R&D engineer at Man Bus and Truck SE, project manager, R&D expert, and materials and surfaces engineering specialist at Volkswagen AG, and also general manager at Bowe Engineering Services. And Gregor, graduated engineer of technical physics, was previously technical manager at Optimal Instruments, and is now general manager at Optimal Instruments. In terms of agenda, we will have our speaker's presentation first, followed by a short video of the ETS system. After this, Gregor will be demonstrating the equipment itself with a second camera feed before we finally move to a Q&A session at the end of the event. Quick note on questions, please do type these in the chat. I'll be monitoring the chat throughout the event, and we'll highlight any questions for this Q&A session. We plan to go for a total of 60 minutes today. We'll also be offering live attendance certificates, the link for which will be shared later in the event, which will allow you to type in your name and generate your own attendance certificate to download. And finally, before we move into the main body of the event, I'd just like to give a little shout out to our website, surfaceventures.org. It features videos from our previous talks, information regarding upcoming webinars, and also information about our team. Okay, so let's release the first poll questions because we like to learn a little bit more about our audience. This first one being, what is your current job/position, which I will share now. Whilst we're waiting for those responses to come in, I'd like to welcome both Gregor and Patrick to the stage to take over. Looking at those questions, looks like we have a good amount of researchers, some employees. Excellent. Glad to have you both to the stage. Welcome.
Happy to be here. Hi to everyone.
Hello.
Excellent. So I'll bring your slides up now. There you go. And with that, I'll leave stage myself to allow you to begin presenting.
Thank you. And thank you to Surface Ventures for hosting us today. And thank you to all participants for listening to us today. We are from Optimal Instruments based in Munich, Germany. Our company is specialized in not only manufacturing equipment for tribo testing, but also finding solutions to solve tribological challenges from the field in the lab scale. And with that being said, we have prepared one very interesting topic for today, which is about coatings and how we can analyze and test the functional properties and functional performance of coatings in a lab test. Our agenda will be a short introduction about the topics. Then we will talk about coatings and their applications, benefits, challenges, and opportunities of technical coatings, friction and wear measurement, how we can obtain functional performance data of coatings. We will present some case studies, and then we will show you one example for a tribo tester in the lab scale, which you already see behind of me, the so-called ETS, Easy Tribology Screener. With this being said, I would like to hand over to my colleague, Patrick Beau, who is the expert in tribological applications in both fields, in the industrial field with his background from the Volkswagen Group, and research with his background of his PhD in the academia and education. He does sometimes professorships at different universities, and therefore I'm very happy, Patrick, that you are with me today, and that we can profit from your rich and great experience directly from the field and from the practice and the research. Please go ahead.
Hi. So welcome also from my side. A lot of positive words already been said. Thanks to Sam and Gregor for this kindly introduction. And I would like to walk you through some applications and benefits and challenges regarding to coatings. And for the very first beginning, I would like to mind up some applications. I guess all of you know from everyday life or from industry. And those pictures I selected because when you're thinking on coatings, it's on the one hand, it's because of optical issues, let's say. But on the other hand, it's all had every time also a technical reason to coat something. Like if you're thinking on a paint job of a car, the first thing which comes in mind is because of the nice color and in the good looking exterior of your car. But on the other hand, it's also for any functional and technical reasons, for example, to prevent any corrosion. And you are able to coat metals, wood, and also textiles, for example, to make sure that they will resist any water or dust on the surface. And if we have a little bit more a deep dive into a technical application, because I guess most of you are interested more in that, when I think about coatings, the first things comes in mind for me is when you are challenged to machining or manufacturing things like drilling or grinding, miling, and also because it's my technical background in the industry field, a lot of coatings are already been applied in engines and gearboxes. So also for combustion engines, but also in the future, and it's gaining more and more of importance, for example, in gearboxes. And that's why I'd like to come along with those pictures. But it's not only on the technical side or on industry sectors, it's also on everyday use or in our everyday life. For example, one of the major impacts of coatings will be medical applications. If you are thinking on the tools the doctors are using sorry, because sometimes the chat comes into my screen and this is a little bit disturbing, but to move on. So in medical applications, it's a wide field of application because of their tools. When you think of their cutting tools and they need to grab something from your body, but also if you're thinking on about knee or hip replacements. So I'm talking about the joints, because it's gaining more and more in importance if you need to implement or implant something into the human body, but also in the household. If you have a look in your bathroom, there are a lot of razor blades, for example, or scissors are also coated, the blades of scissors, as well as pens and all the things in your kitchen. And more important is all about electronics and electronic plug-in connectors. Maybe you're familiar with this gold coatings, but there are a lot of other coatings applied onto electrical connectors. And with this picture show in the very first beginning, maybe I can sum it up on this slide. Typical applications out of our field of experience are, as mentioned, there are functional coatings as well as optical coatings. So optical for lenses as well as for the nice look and feel of surfaces. I showed you some pictures about drills and tools. I mentioned the grinding and milling things. Also medical technology, as I mentioned, the artificial joints. One of the biggest topics in Germany, for example, is our coated engine components. But on the other hand, way more important for our everyday life is, for example, ceramic coatings in the household. So in everyday life, as I mentioned, razor blades. I will give you an example on contact lenses and on mixer tapes in the bathroom. And we saw some pictures of paintings or varnish. So most of all, it's for corrosion protection. But on the other hand, there are more and more very, very thin coating, more and more thin coatings. So we are talking about micrometer or even nanometer in thickness. And one of the typical examples is this gold coatings on electronics or plug-in contacts. But also more and more important, maybe you followed the Artemis 1 mission yesterday. So this rocket, which is on the way to the moon, in aerospace, as well as in sustainable energy sectors, coatings are gaining more and more importance. So this being said, there seem to be a lot of benefits with technical coatings. Otherwise, they wouldn't be implemented or released to the market. One of the major benefits, out of my point of view, is that you are able to adjust the properties of the surface which is getting in contact. So, and there are a lot of possibilities. For example, you could produce multiple layer coatings. And sometimes it's used for defined running-in behavior of systems. Coming back to the applications in passenger cars, in the past it was crucial to drive the first, let's say, 1,000 kilometers very smoothly to make sure all those parts, all those engine components are running in properly. But nowadays it isn't even more necessary. So you can move on full throttle because the critical parts are coated already and they are targeted for defined running in behavior because of a multi-layer coating. Another or more in-depth example is you are able to combine properties of your materials. For example, you can use a very cheap cast iron base material, bulk material, and use the positive properties of those materials, and then add a very hard or super hard surface finish, for example, with DLC coating. So, and the typical things which comes in mind if we are talking on the tribological way of coatings, you would like to have friction reduction because of more efficient systems. On the other hand, wear reduction, and as I showed, for example, corrosion protection. But sometimes more futuristic applications are that you are able to adjust the optic as well as the haptics of your systems due to a thin layer on the top of your surface. And there is another thing which you are able to do with coatings is Sometimes you need to increase your friction. For example, if you're thinking on clutch, if you need to transfer a torque or forces, sometimes you need a very hard and rough surface. Or if you're thinking on screw connections, because you don't want those screws to get loose while operating your system. But if there are benefits, so I really often say if there is a lot of sunshine, there's also a lot of shadows there. And I just want to mention some challenges with these technical coatings, and you can handle those better if you have a deeper understanding. For example, if you are running tribological testings with those solutions. So first of all, it's way more expensive to, it's obviously because if you are using additional technology and additional processes, you need materials, you need time, and all those comes together as an additional cost factor. And sometimes it's missed in discussions, and that's why I pointed it out here. All those coatings and processes need to be, they need to have a suitability for large-scale production, because if you're thinking on, for example, Volkswagen or medical applications, you need to make sure that there is a quality assurance and that the products will work and for millions and millions of parts if you release those to the market. Another thing is, most of those coatings are not so, they are not so friendly, let's say, with lubricants like oil or greases, because those oils and greases already on the market are very often produced and developed for metallic surfaces. But most of those coatings we are talking, they are non-metallic, or they are not behaving like iron or steel. And that's why you need to make sure that not just the counter body and your basic body, which is in contact, are working fine together. So it needs to work also with the lubrication. And on the other hand, there is let's say a new topic on the market. If you're thinking on future mobility, electric cars, there are a lot of copper wires within the car, and they are coated with plastics, and they get in touch with, as I mentioned, already existing gearbox oils, and you need to make sure that your layers, your coatings are tolerating the chemical composition of the new environment. And there's another thing, very obviously, as I think, if you do a coating just on one body or one part of your system, this may lead to suffer the other part, which is in contact, because if one part is very hard and the other is much more smoother, then maybe you can end up with a worn out surface or system. As I mentioned, in lubricated systems, very often there are coated surfaces, but they need to work and interact with the additives within the oil. Typically, example is the so-called ZTTP additive to prevent wear. And last but not least, you need to make sure that your coating, you are able to machine it. So because if you do have manufacturing technologies like grinding or honing processes, you need to make sure that the surface is not as hard and has a good bounding to be able to manufacture it. And before I would like to come and show up some case studies we did, I would like to sum it up. What are the opportunities of technical coatings? First of all, it's very often an enabler for new concepts, because if you're failing with classic material combinations, or you need to have more performance, for example, in engine cars, you would like to introduce new material combinations. And very often they are done with coating processes. And if you're faced, very often I saw suggestions for using coatings because there was a problem or an issue in the field. And a lot of people like to introduce coatings as a problem solver, as I called it here. So just to reduce the consumption, the energy consumption of the, for example, of the car or of the electrical systems, to increase efficiency due to lower friction situation, or to extend the lifetime or service intervals, for example, the oil change interval. Another way beneficial way is to use coatings if you are faced to dry contact areas. Sometimes it's not possible or it's not suitable to use lubrication. And there is a good example in aerospace applications, because if you are running your systems in vacuum or without any G-forces, your lubrication will not stay at the contact zone. And sometimes the areas got dry, and then you need to have a good friction and wear situation, even if there will be no more lubrication in the system. Very interesting opportunity is to not even to introduce it for low friction or high wear protection. It's also possible to integrate new functions. Let's say you can adjust and enable your system for a better thermal or electrical or acoustic conductivity, which will lead to new functionalities within your system. And as an outlook to the future, a lot of people are talking about maybe it's possible to use coatings which can be actuated, and then you will end up with switchable surface properties just on a click on a button. And this will not be able with classical material solutions, and therefore it's sometimes necessary to introduce new kinds of coatings. But on the other hand, if you do have 1,000 possibilities, very often you end up with 1,000 challenges. And that's why I would like to introduce some case studies. And before I will come to those, I would like to talk about who is involved in implementing coatings, so on a technical way, or if you have a look at the industry, and who needs to handle those challenges. And out of my point of view, there are three main topics or departments, let's say. On the one hand, it's research and development, because if you want to implement a new product, new solutions, way more performance or a lifetime increase for your systems, you need to do research and development on both industry as well as university. And the main focus should be on, all your activities needs to be cost effective. So low cost because of low time consuming testings, as well as low needs of parts or testing object specimens, let's say. And on the other hand, you need to have a risk-free method, because it's not possible to use one engine a day to test a new coating, because of failure rates. It's getting way too expensive. And besides research and development, next step will be series production, as I called it. The typical two challenges there is you need to have something for your supplier qualifications, and you need to make sure that you have methods for your quality assurance department. So you need to monitor your systems in the series or in the field. And last but not least is, if you are thinking on purchasing parts, I call it forward and global sourcing processes. All those ladies and guys from those departments would like to have the best performance solution at the lowest price as ever. And on the other hand, gaining more and more in importance is you need to be able to purchase materials, parts, or whole components. And sometimes materials are forbidden. They were allowed in the past, but they got you were not permitted to use them in the future because they will harm the environment or our human body. And on the other hand, when you're thinking on crisis like the war in Europe, sometimes even not possible to purchase parts, and then you need to have a solution for another supplier or another technical solution, for example, a new material combination. And for all of that, you need, to answer all those questions, you need data, and those data are provided by the tribological investigations. For example, the use of tribometer test rigs. And maybe, I'm not very sure, maybe Gregor would like to add something, otherwise I will move on. But here is an overview of the possibilities and the typical applications of our test rigs, for example, the ETS. We call it pre-screening.
Yes, now I'm with you.
Okay, so then move on.
Yeah.
Thank you.
Thank you very much, Patrick. So yeah, this is those are some examples, not only from the coating sector, where we can use the ETS and already successfully use the ETS. For example, for the condition monitoring of products in the field. That means not fresh products, but used products. Instead of full chemical analyses, we can also do functional tests on a test rig like the ETS or SRV as well, to observe the performance in terms of friction and wear protecting properties. We can benchmark products. We can, when talking about lubricants, check the impact of additive packages directly online. And of course, we can evaluate the wear protecting properties of materials and coatings and lubricants as well. This is what we are doing with the ETS, as I already said. Easy tribology screener, a small tabletop tribometer with a linear reciprocating electromagnetic drive, sinusoidal movement. I will show you later in practice how it looks like. With a range of parameters, the normal force from 1 Newton to 300 Newton, frequency from 10 to 70 Hertz. Stroke length is variably adjustable between 10 micrometer and 3 millimeter, temperature adjustable. And the interesting point, we can measure in situ the online wear in terms of wear depth, the very great resolution, and we can also measure in situ the coefficient of friction, which is the indicator of friction losses during movement. The ETS provides quite a nice flexibility with different contact geometries, such as point contacts with different diameters, line contacts. We have different sample materials available for the ETS. They are very easy to be manufactured because of a simple geometry. We have fluid baths in order to run tests, not only under dry, but also under lubricated conditions. And on one disk, you can run at least 13 tests, so that also the material costs are relatively low. And this is what I just wanted to throw in, a little bit commercially, but it's interesting as a background knowledge when talking about the case studies, because then you can visualize on which kind of test rigs those results were produced. Patrick, please go ahead.
Yeah, so maybe I will move on. So as you saw, there are a lot of possibilities with those test rigs. And maybe to sum it up, what are the benefits of those lab scale tests? Just some points. The most beneficial is that you have a method for efficient pre-selection before you will move on into more in-depth or complex testing procedures, like an engine test, or for example, a test with a knee replacement and knee joint within a human body. And due to there are multiple geometries possible, you can change the conditions for your testings. So because it differs if you're using a cylinder geometry or ball geometry within your test, so you can have a look at different applications on the same testing procedures. And as I mentioned before, one of the major benefits for industry is that you need to have less parts or components to produce a variety of results. So if you're thinking on using simple specimen parts like cylinders, discs, or balls, it's obvious that it's way more easy to implement them into your test rig, as well as way cheaper than using for example, engine parts or drills. And one of the major benefits, very often used in university background, you are able to gain system understanding. So you will not just see, oh, the system is failing, or there's less or more friction occurring while testing, but you are able to run those tests with a wide range of parameter setup, and for example, fast movements, slow movements, different temperatures, a variety of loads and contact pressures, and that will enable you to have a wide range of knowledge gain. And you are able to identify the most promising candidates, as we often say, and it's another very important point. You are able to run those tests for your current right now, your challenges right now, but also for the future applications, because you are able to set up, for example, pressure or load situations which are today not suitable for engines, but may become in importance in the future. And this being said, I would like to show you some case studies. All of those are made often with partners, universities, or we did it for ourselves. And the first case study is, as I mentioned, one part is supplier qualification. So the task here was, I would like to walk you through the slide. The task here was that there were 4 different kinds of organic thin films, and they needed to be qualified. And the major goal was to see if there is a friction reducing effect if they come in contact with water, and if the coating will withstand the pressure situation of the testing. And we tested those, and those coatings were applied on very easy geometry discs. And we tested it against a ball, as you can see on the right side. And if you are wondering which application it was, those should be implemented on contact lenses. And the basic idea was that this organic thin films, they look a little bit, on the microscope, they look a little bit like spaghetti fibers, and they will soak in water. That was the basic idea. So if they are dry, they are applied on this contact lens. But if you implement it, set it into your eye, they will get in contact with water, and then they need to be able to reduce friction, because it's not a great experience if you have a very dry contact lens on your eye. Maybe one of you are using contact lenses, and you would like to prevent any damage on your eyeball. And therefore, we use those applications because it's not suitable to test it on human beings. That's why we did it in the lab scale within our ETS. And then I would like to come along with some results here. As you can see, it's an example for this purple colored coating. And on the left side, you will see the conditions under dry conditions. And the task was to find out if there will be a beneficial friction loss if you get in touch with water, as well as will you be able to decrease wear. And as you can see here on the left side, it's the test with the dry situation. the COF was around 0.8, and you can see on the bottom, this blue lines is the wear situation, which is increasing all the time during testing. And on the right side, you can see the testing procedure with this coating get in touch with water. And you see a clear decrease in friction as well as close to zero wear. So this coating, this candidate works very well for the task. But on the other hand, we have some more, and I will come along with the wear situation because it's very easy to set them into the test rig and to demount the tested parts. You can move on to the microscope and have a look at the worn out parts. And as you can see on the left side, this is the wear scar on the ball, and on the bottom there's the wear scar on the coated disc. And basic idea was you don't like to end up with some scratches on this coating or some chips getting out or something like this, and you would like to decrease your wear situation. And you can see it already on this testing procedures because those lines were more on the bottom. But you are able to have a very easy look on this the scale here, less wear and a better friction situation. And then we tested all the other coating variants. And for example, I would like to show you the results for another one, the yellow one. And as I mentioned before, the basic task was that the coating shouldn't come off. So you need to have a good bonding and no scratches on this on the coating. But as you can see here on the dry conditions, there were some scratches already, and there are a lot of debris being produced during testing. And on the right side, even if you add some water, the wear isn't as low as expected, and you will already also end up with scratches on the coating. So this is not suitable for any applications with water on contact lenses. It was very easy to sort out those candidates. And besides that, because there were two of those which are not suitable for those applications, so the already shown yellow one, as well as the green coating here. And you are able to gain more and more knowledge besides those data of friction and wear, because you are able to set up your loads and your speeds, and you will end up with different kinds of wear mechanisms, and you are able to have a deep look and a good understanding what's happening there and why the systems are failing. For example, adhesive wear, so spilling out of the coating, stretches, or the production of wear debris, and you don't want to have them in your eyeball. So this will lead us maybe to the case study number 2. It's more on my technical background within the passenger car and heavy duty truck and bus sector. There was a huge project which focused on fuel reduction in the powertrain. And the idea was to implement low viscosity oils in combination with different kinds of coatings, as well as a geometry adaptation of this piston rings. And typically there is then a group of different people within your facility and your brand, and then you will put on all the possibilities and possible solutions out of your research on a table, and you need to discuss about which solution, which combination of oil, coatings, and geometry adaptations will be most beneficial to challenge the task of decrease the energy consumption, or let's say the fuel consumption of your engine. And typically this has been made by field testing. So you run a truck in the field, for example. And here are some pictures of what will happen if you are using new kinds of coatings and new kinds of oils, for example. And on the top, you can see there was the oil, it's called A here in this example. you had the oil A and the oil B, and those were the most beneficial looking. And after field testing, you will end up with a result like this. So you can see a clear bore polishing and worn out honing on the cylinder liner, and that's why it's a fail oil. It's not suitable for this application, and it's not possible to implement it in the market or your product. And on the other hand, there was an oil coating combination which looks uncritical after the inspection of the engine. And the idea was to show you how much effort is needed to test this in the field. And that's why I would like to come along with some numbers here. Typically, and that's the basic investigation efforts, is if you would like to implement this combination, you need to run, it's also set by government and by standards, you need to run 3 of those heavy-duty trucks for 2 times 120,000 Ks, because the oil change interval is 120,000 kilometers, and you will waste, it's close to 200,000 liters of diesel fuel, and you will end up, for example, with this oil number A in combination with a coated piston ring. Yeah, and you will end up with a solution which is not suitable for your application. And that's one of the examples why it's so beneficial to pre-test it, to pre-screen it in lab scale. And I would show you how we have done this. So we took the original engine parts, so because they were coated, and we used just some small parts to put it in the test rig. So if you have one pair of piston ring and a cylinder liner, you can run a variety of tests. And major benefit is that you are able to use the original parts with the original geometry, and then you can set that up in a test rig. And the thing is, afterwards, you would like to end up with a, let's say, with a one-pager, where you can have a very easy look on which combination, which solution will be the best. And that's what I like to show you here. Typically, at Volkswagen Group, we established this kind of one-pager, and there are a lot of informations, but they are very easy to read, even for management, just because that's the thing. One needs to produce the data and then to present it on management boards to make a decision which solution will come to the market. And for engine applications, a typical thing is you need to be aware of scuffing, because if you end up with a adhesive failure in your engine, the engine will stuck and won't run anymore. So, and it's very easy to read, because on the left side you will end up with your results of your reference. So that's the actual design. And then you can have a comparison to the other candidates, for example, those 4 combinations, and you will see the higher the points, the higher the resistance against scuffing. And you will have a clear understanding that the red one, the red candidate, is the best because it's the most robust solution. But also suitable to use the green, the yellow one, or even the blue one, but it's way on the bottom, and it's not better than your reference. So if you sorted out that maybe those 4 candidates are good to go, you would like to have some information on where, and that's presented on the right side. As you can see here, the higher the bars, the more where it will occur. On the left side, it's the baseline, it's the reference. And as you can see, all candidates, you will end up with more wear, because the system is not so suitable for this engine applications. And if you're using a very hard coated piston ring and a very thin oil with low viscosity index, you will end up with more wear in your system. It was very new information, and yeah, typically it will take a while to ride all the trucks in the field to find out that your system will be totally worn out. And then talking about friction, you will end up with data, and you can display your data for friction tests. And we do have 2 procedures. So it was a short-term test fresh oil, fresh parts, and it's shown on the left side. So let's say initial friction situation. And as you can see here, all those solutions do decrease the friction, but as you remember, they will increase the wear. And you are able to run those test rigs overnight for long-term tests. And those long-term tests are also been made with aged oil, because if you're running a machine in the field, you will end up with worn-out situations on the surfaces, as well as aged oil conditions. And as you can see here, the friction is for all the variants also decreased compared to the slightly gray line of reference. So, and it's very easy to mark the most beneficial candidates. Let's say for scuffing, it's the red one. For where the situation of the yellow one is the best, and so move on. So at the end of those tests, being made within 2 weeks, you are able to say, okay, if there is a need to implement low viscosity oils and the coating due to friction reduction, the most promising are the red and the yellow one. Within 2 weeks, without any diesel fuel, was way beneficial, and this method is implemented at the Volkswagen Group. So they are investigating their solutions with this method and with the machines of Optimum. And then another example, case study number 3 is, and there was a quest for global sourcing, a global sourcing topic, and it was regarding a mixer tape. So if you are thinking on this mixer tape, there are slightly amounts of grease within this lever arm here, and there was a long list of requirements. For example, they would like to purchase, they want to sell those mixer cartridges with the grease inside in different markets. And for example, there were some requirements for this grease to be kosher, halal, or even vegan. Obviously, this grease needs to be non-toxic, because it's, you will use it in combination with water, and it needs to run with water, low temperature and high temperature water, because you would like to use cold and hot water on your mixer tap. It needs to provide a kind of a sealing solution, because there are rubber rings in there, and this grease needs to work together with this rubber combination. And another very interesting point out of my point of view is those greases will have an effect on the haptics of this lever arm. So if you open up or close the lever of the mixer tab, the grease needs to work on a constant level of friction. And for future applications, more and more of those mixer tabs are getting also electrified. And there is a little actuator motor in there, and to make sure the system will run over the lifetime, the forces within this actuator needs to remain constant. Otherwise, this will end up with a failure. And we are showing up this example because the partners, which I will show you on this thing, they are coated with a kind of a ceramic, and we implemented those partners within our ETS test stand. So sometimes it's very easy to use the original parts. On the other hand, you need to abstract it and use simple geometries like this ball, and we implemented the grease. And then we did our testings, and I would show those here. So the basic idea was we need a low friction level, and no additional wear should come along with the one grease or the another grease. And so as I told you, we did the testings for room temperature water and hot water. So this, because that's why there are 2 bars. We set it up in the test rig for room temperature and 65 degrees. And very obvious, if you are running the system on dry conditions, you will end up with the highest forces on friction, and you are able to decrease the friction while using greases. But very important, and I would like to highlight, is that something seems to go wrong here with this, because sometimes you end up with a friction level like here, or sometimes with a very low friction level. And as I already mentioned, the main task was that the friction behavior needs to remain constant over the lifetime. And that's why we have we had a look at the friction data. And as you can see on the left side, it's the data for the room temperature test, and on the right side, it's for the high temperature of 65 degrees. And as you can see, the friction level is for this grease number 1, very constant, very smooth until something is happening there. And this behavior even increases or gets more and more critically if you raise up the temperature. And that was very important for our customer to see, is there an influence on the temperature, and will the system remain constant friction levels due to the whole life cycle and all those movements which one would make while using this mixer tab. So you could say this grease number 1 isn't beneficial for the system. You can sort it out. And then on the other hand, we tested a more beneficial, more promising combination. This is grease number 3. And as you can see here, maybe I can go back and forward. The scaling is the same. Way lower friction level, very promising. And this remains constant also if you implement it with higher temperatures. And then, besides friction, you need to have a look at the wear behavior, and that was very, very exciting and fascinating, because as you can see here, if you are using this mixer tab without any grease, because there was the idea maybe this ceramic coatings are good to go without any lubricants, without any grease application between those, and we ended up with very, very low wear rates for the dry contact. And what what nobody expected is that if you are implementing the, let's say, the not so promising grease, or a grease which will not work with this application or those surfaces together, you will end up with much higher wear rates. And it's unexpected, let's say. But as you can see, this grease number 3 with this very smooth wear friction behavior will also be able to decrease the wear. And as you can see also, there is a slight difference between low temperature and high temperature testings here. So after we have run all those testings, we could come along with this data to our customer and say, okay, if you should implement a grease, because it would be way beneficial for your friction behavior, and that's good for the haptics of your customers while they're using this mixer tab. But you should avoid to use the kinds of grease number 1 and 2, because they are not so beneficial. Please move on with grease number 3. So, and this being said and showed up, maybe it's now a good point to hand over to Gregor and Sam again, to let you guys have a look at this test stand.
Yes, thank you. We will try to do the demonstration very quick.
Mm-hmm.
We only have 4 minutes left, I think.
It's for our allotted time, but so long as the members of the audience are happy to stay a little longer, we can do that. Would you like me to cue the video, or shall we skip straight to the demo?
Yes, we will jump straight to the demo.
Okay.
And maybe you can post the link to the video parallelly.
Mm-hmm. Absolutely.
And now I'm sharing the screen of our ETS unit. You can see me in the webcam, how I operate the unit. You can see the ETS itself here. on the webcam, and you can see the screen parallelly. So the ETS is equipped not only with a mechanic test rig, but also with sensorics and a software, of course, that allows you to automatically operate the tests. As you can see, I already installed the samples into the test chamber in order to save time. The samples are principally looking like this. Those are discs, in this case steel discs, on which a DLC coating is applied. And the task which we have today is to compare two different variation of coatings, of DLC coatings. This one here is the reference that I'm showing you in the webcam. I can also show you the result of this reference on the screen. And you can see here in red, we represent the coefficient of friction. The tests were run under dry conditions. And the coefficient of friction is about 0.2, 0.21, while the wear remains very, very low and doesn't increase over 1 micrometer in depth. Parallelly, we are starting now the test with another sample. I have to hide this here. There we go. And now you see how the normal force is applied here to the samples. The axis moves down and gets in contact, or brings the upper sample in contact with the lower sample. In this test, we are using a line contact. Now a short start delay starts to count down in order to get a thermal equivalency between all trial partners, and then the test starts automatically. And what you can see when the test is starting, you have immediately the values in the displays of the unit, as you can see here and here. On the left-hand side, you see the coefficient of friction. On the right-hand side, you see the actual wear. And what is very interesting with this coating that we are testing here at the moment, that if you remember our reference with 1 micrometer of wear over the entire test, this coating immediately increased to 2 micrometers. So already after 1 minute of test, the wear is relatively higher than the reference. And with that, you could save time and immediately stop the test, because this sample here is already disqualified. Its performance is worse than the performance of the reference. But in terms of friction, if you're searching for friction reducing properties, you see that the coefficient of friction is significantly lower than with the reference. So maybe it's worth to leave it running a little bit and to judge later which is the best candidate for your application. Parallelly on the screen, you see the online values in terms of temperature, load, frequency, COF, stroke length, and wear. What I wanted to show you parallelly during the test, while the test is running, is on the one hand side, how easy it is to set up the parameters for the test. You can apply a name for a parameter set, and then you can easily adjust the test parameters. You can add more steps by copying the first initial step, and you can vary the parameters then over the entire test. And you see immediately in the online view how the parameters will change or will look like during the test, during the set point. One other short thing I wanted to show you is the compare mode. So when you run a bunch of tests, and if you have different candidates, then you can easily compare all the results within our software. As you see here, the black and gray lines are the wear measurements of different materials, and the red lines are the coefficient of frictions of those materials. In this case, we ran lubricated tests with a steel counterbody against bronze, brass, aluminum, and steel. And you can nicely see on the one hand side, as you learn it in the lectures, the wear behaves according to the theory, with a sharp running in, and then it's becoming more and more stable with a constant wear rate. And on the other hand side, the coefficient of friction stabilizes after a short running in period. And what you can nicely do then is you can benchmark the different products in terms of wear and friction. For example, the black line is lubricated steel contact with the dark red COF. And for example, the worst performing pairing is the steel against aluminum in terms of steel against bronze in terms of friction. But as the surfaces wear quicker than in other cases, the COF becomes relatively low because the surface pressures are reduced, and you have a nice lubricating film between the tribo partners. This is what I wanted to show you before going back to the live view of our test. And when we look at the current results, we see that the friction also increases during the test, and the wear is already at 4 micrometers. You can see that we have a relatively harsh running in wear compared to our reference, and this now definitely disqualifies this candidate in comparison with the reference, which I'm going back to it at this moment, which remained all the time stable at 1 micrometer and a COF of 0.2. With that, I'm closing this demonstration here, stopping the test in order to don't have noise in the background. And I'm thanking you for your attention.
Excuse me. Thank you very much for the demonstration, Gregor. It looks like a fantastic system, and a lot easier than many of the tribometers I've used in the past, certainly. So it's great to see. Okay, so I think at this point, if we can, we'll take the screen share off of that. We'll move to questions quickly, and then we'll close up the webinar. So we had a few questions here. I got one from Vikash, who I think is asking a bit more about general kind of coating studies here. I'm not sure whether either of the two of you have worked with electroless coatings, but he's asked about the future of electroless coatings, as he's currently doing a PhD in that area. Do either of you have any insights into this? I think I might have some things to add, if you don't.
Yes, so about different coatings and their properties, it's we could discuss long and long. So I would I would suggest that you contact us offline after the event, and then we can have more deep dive and more discussions about those scientific questions.
I mean, in terms of electroless coating generally, I mean, it is used a lot in automotive industry, as far as I'm aware, for bearing use. So, there's various different things with, different electrolytes used for this, study of coating structures, tribological properties, you know, we could go on as Gregor said, but there are a lot of questions still to be answered with this, as there are with pretty much every field of coding study. So I hope that helps somewhat. And let's move on to the next one, another one from Vikash, who has
Maybe
asked,
I can add
please.
the typical candidates which I for myself investigated in the past were nickel plating and chromium, because they are very easy to implement or apply with this technology, and it's a huge sector, and it will be in the future as well, because it's a good. Yeah, but you will end up with a smooth surface, way smoother than, let's say, plasma vapor deposition or something like this, with high possibilities of very thin and accurate coatings.
Yes, yeah, I think the general sort of analysis for coating thickness and optimal coating properties is much easier with both electroplating and electroless plating. So it kind of opens doors for, I guess, faster studies of things. But moving on to Vikash's next question: what are the simulation-based studies available for coatings? Any insights there? I mean, that's again another very open question.
Before answering, I would like to ask you for your understanding, but I have to move to another meeting. But maybe Patrick can stay a little bit longer to answer the questions. And I thank you for everything and for joining us today.
Thank you very much, Gregor. Okay.
I'm not pretty sure if I get this question right.
So it seems very general. Like what sort of, to me, it sounds like what kind of simulation-based things could you do for coatings? In which case, you could, to my mind, there's a few things. I mean, residual stress modeling is always a big thing, especially for if you're looking at multi-layer coatings, dissimilar materials. Let me think. What other things you could do? Modeling of coating nucleation and growth. If you have some thermodynamics modeling, that's something you can do. Tribological modeling as well of wear. If you have a coating that is not corrosion resistant, you could do both erosion and corrosion modeling. It really depends on what your application is and what you want to get out. But I think as a general thing, craft your simulations to fit to an experiment, so then at least you can see whether the two make sense, and they should complement each other. It's the one thing I always think with any kind of simulation based things.
And I used a simulation software called Film Doctor in the past, and it was very cool to see which kind of stress got transferred through this thin layer of coating to your bulk material, because sometimes you will end up with a bad bonding, and that's why you need to use the multiple layer solution for better bonding, and less chips come off this coating and so on.
Yeah, absolutely. Film Doctor is very good. I've played a little bit with that as well. Okay, we got another from Vikash who's asked, what is the best method to calculate volume loss for finding wear rate? A, by weight difference, or B, taking a 3D image of the wear track using an optical profilometer?
Absolutely, I would like to prefer the 3D imaging because we are talking about microns of film thickness and very less wear rates. If you have a look at this this presentation, and very often it is impossible to differ by weight. And on the other hand, it's not just to measure the wear volume, let's say, or the wear rates. It's also because have a look at what's happening there. Was it abrasive wear or adhesive wear, and is there some sorts of debris on the surface and so on? So absolutely, I would like to prefer 3D imaging.
Yeah. Yes. No. I absolutely agree. I think you'd only do mass difference if you were measuring huge amounts of wear. But for a lot of these coating studies, you simply wouldn't. From Viorel, apologies for mispronouncing that. Why was this sinusoidal movement chosen for the tribometer testing? I think there was a further clarifying comment just to say, I think it was in fact reciprocating motion. So we just check that is the case.
Yeah. So it's a movement from left to right and from right to left. So stopping from velocity of 0, accelerate to the other side, stopping, acceleration, and so on, like it's done in the for ceilings on shafts or in the engine also. And there is another possibility to run tests with rotary drive. It's just another test rig. It's called SRV machine. So there's another tribometer which will enable this continuous movement, let's say.
Yes, very good. Excuse me, sorry, moving on to the next question. Sonny has asked, I think this was case study 1, just to clarify, what was the thickness of the organic coating used for the contact lenses?
That differs because, as you can imagine, they needs to be as transparent as possible because you want to look through them. And the film thickness or the thickness of this coatings differs with the type of this coating. And that was another point within this study, which thickness of this coating is needed to make sure that this contact lens will last, because there were some contact lens applications for just one-day lenses, but there is another one which needs to soak in water and oxygen, and because you can let them rest within your eye for 30 days, without changing the contact lens. So that differs with the application.
Okay, thanks. And then final question here. Also from Virel, asking any recommendations on multi-layer coatings, i.e. coatings made of 2 or more different layers. Are they suited for engineering applications? Thank you.
Very basic question, because there are a lot of. Typically, we are using out of all my experience within passenger cars and coatings for engine components, we always need to use. It's not a wish, it's a need to use multiplayer coatings, because it's another process and it's much more expensive and time consuming. But to be able to set up the properties you would like to have, you need to do this multiplayer layer because of bonding, surface roughness, as well as thermal conductivity, maybe electrical conductivity also. And very important thing is that you are able to have a smooth surface after applying this coating, as well as for the first running in hours or minutes. And that's why you would gonna go with a multiplayer layer coating. And there are a lot of combinations already on the market.
Yeah, absolutely. I mean, I worked with, my PhD was focused on DLC coatings, and they were all multi-layer, adhesive layer, stress relieving layer, and then the top layer of actual DLC itself. I mean, one of the things to note, I don't, again, not sure the application for this, but multi-layers are really good for impact resistance and really good for balancing residual stresses. So you can design residual stress profiles with different materials or different thicknesses of coatings. So that's one thing to sort of note with this, but it really depends on the application.
And it's very crazy when you're thinking of DLC layers, because it's a thickness of nanometers.
Yes.
You have a multi-layer coating. It's absolutely crazy what it's possible today.
Yeah, it's really, really interesting to sort of take a look at those when you're sort of like, because often it's like chromium or titanium layer, and then something like a tungsten carbide, and then a DLC. But yeah, it looks really nice when you start cross-sectioning them with focused ion beam and things like that. Yes. Okay, so I think with that we have all of the questions done. For anyone who has not yet downloaded the attendance certificate, the link for that is in the bottom left. So please go ahead and click on the little featured action there to get your attendance certificate. After this, it will not be available anymore. So if you want it, please get it now. So with that, let's close the webinar. So I just wanted to say thank you very much, Patrick, for your talk today, and also, though he's not here anymore, thanks to Gregor for the demonstration, and thank you very much to Optimal Instruments for partnering with us for this talk. We wouldn't be able to have great events like this without our partners. So with that, I'd just like to highlight our next webinar, which is Green Tribology for a Sustainable Future with Professor Mitjan Kallen. So please do go ahead and register for that. I'll put the link up for that now. The registration links will also be available on all of the Surface Ventures social media and on our mailing list very, very soon. So you can register for that. Just once again, a shout out to our website. And we also have our fortnightly newsletter, Modern Surface. By signing up to our mailing list, you will receive this. And the next issue, apologies, of that newsletter will be available tomorrow. So please go ahead and sign up on our website if you want to get that. And finally, I'd just like to say, we are very dependent upon our community. So please do advertise these lectures to your colleagues, to your friends, if that would be of interest to them. So with that, we'd like to sign off. Thank you very much for joining us today. And thank you once again, Patrick, for your great presentation.
Thanks for having us here. I appreciate it. It was my pleasure.
Thank you.
Have a nice afternoon and evening. Bye-bye.
Thank you.
Bye,
and you too. Goodbye. And goodbye, everyone in the audience.